All right, so here again, we use our vertex and a point on a graph to find the general form of the quadratic function. All right, so first we'll find the standard form. We'll go ahead and multiply it all out, and then we'll get our general form. So what do we know? Well, again, we know we're going to have some y equals a times x minus h plus k, and that's squared. Okay, so let's plug everything in on the first go around so we don't have to worry about anything, because we can plug in our x and y, we can plug our h or k, and then all we have to do is simplify. So that will give us a. So y is 1 equals a times x, which is 10, minus h, which is 3, and then that quantity is squared, plus k, which is 2. So we have 1 equals a times 10 minus 3 is 7. 7 squared is 49, and then plus 2. So subtract 2. And so then we have -1 equals 49a. So a is going to be equal to a -1 over 49, because we're going to have to divide both sides by the 49. So we have a really weird a, but it's negative, so we know that this is going to give us a max, so it's going to be some kind of quadratic that looks like that. All right, so let's go back over here. And so f of x equals that -1 over 49. And again, we don't care what the a is. That's just what a is. And then we have x minus 3 squared plus 2. So that is our standard form. So if they'd ask us for that one, we're done. But they didn't. They asked for the general form. So now what we have to do is we have to square this, then multiply by this, and then add this. So probably it's going to get complicated. So again, that squared, we're going to take the first one and square it. Then -3 times x is -3x times 2 is going to be a -6x. That squared is 9, and then plus 2. Okay. All right, now what do we do? Well, now we have to multiply. So that gives us f of x equals -1 over 49 x squared. That's going to be plus 6 over 49 x. And that's going to be minus 9 over 49, and then plus 2. Okay, so now what do we do? Well, now we have to add those two together. And so what does that give us? That gives us, we have to get a common denominator. So 2 times 49 over 9, or 49, sorry. And that's going to give us what? 98 over 49. I don't know, for some reason my brain doesn't want to know that. Yep, 98. And so that gives us 98 over 49, and then minus the 9 over 49. So we're just doing this here part here. And so the 98 minus the 9 is going to give us 89 over 49. So what we've done is just that last piece. So now we have f of x equals -1 over 49 x squared plus 6 over 49 x, and then we work that out as minus 89 over 49, and that is going to be our general form. And again, I just worked this out and did the, times 2 and got the 98 over 49. Then I subtracted the 9 over 49. And, oh, wait a minute, that is a plus. I don't know what I was thinking, because we did subtraction already. Never mind. So that is plus 89 over 49. All right. So glad I went back and talked it through, but that is a plus then. Okay. All right. So that would be our general form. And again, all we had to do first was find our A, and then plug it in, and then do a lot of multiplication, and then a little bit of adding and combining two fractions there. All right, what about this one? Another application. So what do we have? So among all the pairs of numbers whose sum is 6, find the pair with the largest product. And what is that product? All right, well, what do we know? That's what we need to write down first. So we know x is going to be, let's call that the first number, okay? So because we're going to have two numbers, we're adding them together and we get 6. So what do we know about that? Well, then 6 minus x, that's going to be our second number. Because if we add this plus this, 6 minus x plus x, that gives us 6. So that works. And they want to have the largest product. Okay, well, what does that give us? Well, let's call it f of x. I don't know, because it probably could be p of x, maybe even, but we'll say it's f of x because it's easy to work with that. And so that's going to be x times 6 minus x. So that's our first number. And our second number, when we take the product, that's going to be the one with the largest amount. So that'll be 6x minus x squared. And that's f of x. Now, that's not how we write them. Minus x squared plus 6x. That's a negative, so a is less than 0, so it's going to be a max. Guess what? That's what we're supposed to get, so that's good. If you work this problem out and setting up a function, and you get like maybe that was positive, and it was supposed to be the largest, but you're going to show the smallest, that's when you know, hey, I've done something wrong. But when you go and you say, okay, that's going to be negative, that's a max. Oh, hey, and I wanted the largest, kudos to you. You've already got half the problem solved, that you know you're doing the right thing so far. Now what we have to do is find our h and our k. So that's going to be a minus b. Well, b is 6 over 2 times a, which is negative 1. So basically, negative divided by negative is positive. 6 divided by 2 is 3. Okay, that's good. Now what is k? All right, well, k is, we plug in at 3 here, so it's going to be a minus 3 squared plus 6 times 3. So it's going to be a minus 9 plus 18, and so that's going to be 9, okay? So what does that tell me? Well, that tells me that the product is going to be 9, because that's what k is, and that we know that x is going to be our 3, because we know that it's h comma k. X is going to be what h is, y is going to be what k is, and so if y is going to be that's the product, and x is what we plugged in, so x equals 3 is the first number, and 6 minus x equals 6 minus 3, which is equal to 3. That's going to be my second number, okay? And so what is the product? Well, the product is 9. So that was really what they wanted, was just the product. But we first kind of had to figure out what are the two numbers. Well, it was 3 and 3, and 3 times 3 is 9. And if you think about it, any other numbers that we put in here, say we had, maybe we had a 2. So 2 and 4, that's 8. What if we had a 1? 1 and 5 is 5. And so really, logically it makes sense, but you have to kind of show all your work to get to it. And so that then gives us what the product was, and we already knew that it was 3, and then also 3 for the second one. Okay. All right, what if we have this one? So a farmer finds that if she plants 75 trees per acre, each tree will yield 20 bushels of fruit. Okay. And she estimates that for each additional tree planted per acre, the yield of each tree will decrease by 3 bushels. How many trees should she plant per acre to maximize her harvest? All right, well, so we know each additional tree planted per acre is going to decrease it. So let's let x, so we need to kind of figure out x. That's going to be the number of additional trees planted. Okay, so let's let that equal that. Okay. Now, how many trees does she plant? She's going to plant 75. That's the max. So every time she adds another one, if we have number of trees she eventually is going to plant, well, that's going to be 75 plus x. That's going to be each additional tree. And how is her yield going to happen? Well, it's going to be she maximizes. So number of its bushels, that's going to be equal to the max, which is 20, minus 3 bushels per tree. So 3 times x, okay? So this is what we're kind of doing. And so what we want to do is we want to maximize how many trees she should plant to get the biggest harvest out. And so what are we going to do? Well, if we work this, what is going to be how we figure that out? Well, our max harvest is going to be the trees times the bushels, because each tree is going to produce X number of bushels. And so if we take and say f of x equals 75 plus x times the number of bushels per tree, basically. Oops, not 30x, 3x. This should give us, the maximum number of bushels bushels for the number of trees she's going to get. And so what we have to do is we have to multiply here. So if we multiply 75 times 20, that is equal to 1500. And then 75 times that's going to be minus 225x, then plus 20x minus 3x squared. And if we write this in decreasing powers of x, that's be minus 3x squared. Subtract 20 off there, that's going to be minus 205x, and then plus 1500. That's going to be our parabola. And this a is less than 0, so that's going to be a max. And we want to maximize her harvest, which this function should do. Okay. So what do we want to do? Well, we need to find h and we need to find k, kind of. So let's go ahead and do that as we always have done. H is minus b. Well, that's a minus 205 over 2 times a, which is a negative 3. That's going to give us a negative, because that negative times that's going to be positive. And so we'll take 205 divided by 6, and it's 34.1666. Can we have parts of trees, because x is the number of trees, and so it's going to be approximately 34.166, and it's a negative trees. Nah, I'm just going to say it's approximately negative 34 trees. Okay, so that's where I'm going to say it's what it is. Now, what does that tell me? Well, that tells me I'm going to have, that's how many additional trees we planted. Well, we want to subtract that, so we want to take off that many. And so if I take off that, that's where I'm going to subtract it here. And so I'm going to plug this in here, and 75 minus 34 is going to be what? 75 minus 34 is going to be 41 trees. So that's going to be my optimal. Okay. Now, how many bushels is that going to be? Well, that's going to be 20 minus 3 times the x, which was 34. And that's going to give me, and it's a negative 34, sorry. 20 plus 3 times 34, that's 122 bushels. Okay. Now I'm doing this kind of two ways here, because now what if I took 41 times 122? That gives me 5,002. And that's going to be a total bushels. That's bushels per tree, but the total bushels, I'm not writing down my bushels per tree. All right. So that's going to get me the max number of bushels. But what if I just went ahead and solved for k? Well, that would also give me the max number of bushels, I hope. So let's see if it does. Minus 3 times. Now I'm going to plug in a negative 34 and square that. Minus 205 times negative 34, and then plus 1,500. And I'm hoping that gives me the same as that 5,002. So negative 3 times negative 34 squared. And then it's really going to be plus 205 times 34 plus our 1,500. And that gives me 5,002 as well. Okay. Now, how many trees would she need to plant for that? Well, she's going to need to plant 41 trees to maximize her harvest, okay? And then the harvest would be that much. So that's the number she needs to plant to reach the max harvest of 5,002 bushels. All right, let's see if there's another one. There's not. All right, so that's all I have for this section.